Okay, myself, Dr. Sharma. So, morning I dedicated on video. So, I already two video completed. The first video is on stress test, simple stresses in the machine components. The second video we discussed about the basic concepts of design in the second video. That is the third video. So, we are going to discuss here the mechanical properties of materials and the stress strain diagram in this video. It is very useful to the being mechanical students. They can go through, they can study, they can score good marks. So the mechanical properties of material, we have strength, stiffness, hardness, we have resilience and reactivity, elasticity, right? And we have one more is toughness. So these are all different mechanical properties where we are using for all the materials. So let us discuss first what is strength. So in the first video we discussed what is stress, and today we are going to discuss about what is strength. Strength is the ability of material to raise the loads without fracture due to excessive stress is known as strength. So it is the ability of material to raise the load without failure due to the excessive stress is known as strength. So strength of the material, strength of the member is depend on the type of load acting on it. So if you take a general example, so difference between the stress and strength is very simple. Stress is internal resistance offered per unit area, that is called stress. Strength means the maximum capacity of taking the load, that is called strength. Example, I will give a person can eat 10 idli at the same time, so one more person can eat 100 idli. So his capacity of eating 100 idli is more. He cannot eat 101. He can eat 100 idli, but that is the maximum capacity of eating is what we call the eating capacity, that is maximum strength. So 101 we cannot eat, that is his, after that it will fail, it will come out. That is called the capacity of the person or it is the strength of the person. Next, stiffness, the ability of material to resist the deformation induced due to load is known as stiffness. So usually this is, when I say material is more stiff, undergo smaller deformation when subjected to load. Material should be more stiff, undergo smaller deformation when subjected to load. So such type of stiffness you can find in spring materials, right? All the materials like spring material you can find stiffness. Next, hardness. So hardness, we are usually doing hardness property everywhere. We are doing local hardness test, we are doing thin hardness test. The hardness is again a material property to raise the surface, scratch, penetration, abrasion, indentation, and the function of stress required to produce a specified type of failure. So whenever a material is running a long time, naturally you can find some abrasion or scratches on the top of the surface. Right? It is generally expressed as an important property, right? Involved in the design of components like you can find in gears, sprockets, chains, right? You can find in where there are cams where they are constantly rubbing action. So you can find ball bearings, right? Cam forward. So such type of material they are in contact with each other, and when they are in contact with each other, you can find some type of hardness property, right? You can improve the property by adding different materials by the same material. So that is about the hardness. Resilience is again the ability of a material to absorb energy and deform elastically due to and it return to it when unloaded is known as resilience. Resilience also we can find in the springs. Usually the modulus of resilience is given by U0 equal to sigma square by 2E. Okay, this is the modulus of resilience. Amount of energy stored. Resilience is expressed on the area under the structured curve. Right, modulus of resilience is given by energy stored per unit volume up to distance, that is given by sigma square by 2E, which is called as resilience. It is again a property in the spring material. So that next we have ductility. So ductility is defined as the ability of material to deform to the greater extent before the sign of time. You can bring it to small waves in ductility, right? You can bring it to small waves subjected to tensile force. In other words, it's a permanent deformation that you can find in steels, coppers, and aluminum. That is called ductility, where you can bring it to small waves, right? That is called again one more property of material. Next we have elasticity. Very simple, elasticity of property of material to regain its original shape when subjected to load after a deformation. When you remove the load, it will come to its original state. It will come to its original state. The degree of elasticity varies from metal to metal. The amount of elastic deformation of the metal undergoes is very small. So that is again an example. You can take rubber materials on rubber material, they go on glass steel. Next, we have toughness property. Last property is the ability of a material to absorb energy in a plastic range is known as toughness, right? So toughness we can use calculated from the area under structure diagram. So it is given by T equal to toughness is given by T equal to sigma I plus sigma sigma u by 2 into epsilon A, right? So we have sigma y, epsilon is the strain at fracture point, sigma is the yield stress, sigma is the ultimate stress. You can calculate. So more when I say particular tough, it undergoes ability to bend, it undergoes ability to twist, it undergoes before failure takes place. So all steel materials you can find the toughness property, right? So these are all different properties of the material.